So okay, let us start for today. We'll be doing a problem on Khoslas theory. Okay, we have studied the theory, we have seen what are the formulas and everything. Now we'll be tackling one problem. How the problem will be executed, we'll be seeing to it in this particular class. Okay, so anywhere you have any problem in understanding, you stop me then and there and you can ask me. Okay, so just for your reference, these are the particular formulas. Your entire structure was divided into three simple structures, right? The one was your horizontal floor with negligible thickness considering the upstream and the downstream pile. Another one was the only the thickness of the floor was considered for evaluation, and the last structure was the horizontal floor with negligible thickness considering only the intermediate pile. So considering all these three types of structures, we have designed these formulas. Okay, so at the end what needed to be done was to do this type of corrections, right? We have seen this. What are the corrections? One is for the mutual interference of piles, another is correction for the thickness of the floor, and the last one is the correction for the slope of the floor. Okay, so what was the correction for the mutual interference of piles? What was that? We have found out the values for this particular, means E1 C1 D1 and E3 C3 D3 considering the first simple structure, right, or simple profile you can say. So in the first profile you have neglected this intermediate pile, but for this intermediate pile we have seen that there will be a change of C1 and E3. So it has to be incorporated in your value that you have found out from the first simple profile, right? Considering the first simple profile, we have found out these particular values for the upstream pile and for the downstream pile. But at that particular point, we have considered that there is no intermediate pile. So when you incorporate this intermediate pile, these values will be changing, that is C1 and E3, and this particular change is given by this particular formula. Okay, so it needs to be calculated accordingly. And similarly, when finding out your pressure for the intermediate pile, the value of key points or the pressure key points, okay, that is E2, C2 and D2, these particular values when you are finding out for the intermediate pile. So we have not considered these two end piles, right, the upstream and the downstream pile. So considering those, there will be a change of pressure at E2 as well as C2. There will be a change. This E2 will be changed because of this particular pile, okay, and this C2 will be changed because of this particular downstream pile. So there will be a change of the particular values. So it has to be calculated accordingly, and we have to add or subtract it according to the value that we have got. So I am again telling you that if your pile, if your influential pile, suppose you are finding out the pressure for this particular pile, okay, and your interference pile is the intermediate pile. So if the influential pile is situated on the downstream side, then we will be adding up a value. So the correction is a positive correction. We have seen what is the logic, we have seen that. So when you when the influential pile is situated on the or located on the downstream side of your reference pile, this is your reference pile, okay, and this one is your influential pile. Considering we are finding out the values of E1, C1 and D1, for those particular values the influential pile is this pile number 2, okay. So the influential pile is situated on the upstream on the downstream side. So this value, there will be an addition to this C1 value that we have calculated. So here it is known as a positive correction. And if your influential pile is situated on the upstream side of your affected pile, then it will be a negative correction. So the correction of E3, this will be a negative correction. Okay. Similarly, the value of E2, okay, when you are considering this this particular E2, sorry, this particular second pile, this 2 number pile, okay, when you are finding out the values of E2, C2 and D2, so for that pile, when you are considering the influential pile as the pile number 1, so there will be a change for the pile number 1, there will be a change in the value of E2. So your pile number 1 is situated, that is the influential pile, is situated on the upstream side. So this E2 value will get reduced. So here it will be a negative correction. Similarly, this C2, this value has your influential pile, that is pile number 3, situated on the downstream side. So this C2 value, there will be an addition, or you can say a positive correction will be there. So this has to be incorporated while calculating all the values. Okay, we will be seeing to it when we will be tackling the particular problem. Similarly, the thickness of the floor, I have told you, we are considering only the horizontal, only the floor as a horizontal, just a horizontal sheet without a negligible thickness. So this E1 dash, C1 dash, these have been found out, but actually what we need to do, we have to find out this E1 and C1. Okay, so we don't need these particular values. We don't need these have been found out. Okay, from the consideration that the floor of negligible thickness has been evaluated. Okay, so these have been found out, but what we actually need is these values, right? These are known as the key points. So we need these values. So see, we have to do it just simply by unitary method. Okay, here there will be a particular value. Suppose here the pressure head is 80%, okay, here it is 70%, suppose, and here it is 60, suppose we are considering this. So we will be doing only by unitary method, means we know this thickness, okay, this thickness is known to us, the total length, the total depth of the pile is also known to us. So we have to do it only by unitary method. We have to find out this particular value. Okay, so here there will be a subtraction. Okay, so for the downstream, for the upstream side, for the pile, look, this is the pile. Okay, so this part is the upstream part, right, and this part is the downstream part. You can see that. Okay, so for the upstream part, we have to do what we have to do. As we go down, there is a reduction in the pressure, right? So from 80 to 70, from 80 we have to subtract a particular value through unitary method. So here for the upstream side, it will be a negative correction. Okay, and for the downstream side, you can understand this 70 has been reduced to 60. So 60, here somewhere there will be some, suppose it is 63, suppose, and here it is 76, suppose. Okay, sorry, here it will be, if it is 63, here it will be 77. Okay, so you can understand there from 80 it is being reduced, and the 60 has been increased to 63. You can understand from 70 through this side it is being gradually decreased to 60. So somewhere between it should be greater than 60. So here it will be a positive correction. We have to add a particular value to 60, and here we have to reduce, or you have to subtract a particular value from 80. Okay, so on the upstream side there has to be a negative correction, and on the downstream side there will be a positive correction. Okay, these are simply the unitary method have been carried out here. Okay, and what is the correction for the slope of the floor? So we have seen that yes, considering this particular slope, there will be an increase of pressure, there will be a decrease of pressure, because if the floor was kept horizontal like this, then the water pressure out here that would be generated here will be more than when you are considering this slope, because the water has enough area, so that there will be a reduction in the value of C2, okay, that you are finding out. So here there has to be a particular value. If the slope is going towards the upper side, it is going up, okay, then there will be a reduction, or you can say the negative correction for slope will be there. And in case of a slope like this that is going down, here you can understand the area is being reduced, so you can see the area is being reduced, okay. So here there will be a positive correction, this E3 value there will be a positive correction, okay. So I hope you can understand this. And what will be the correction through this particular table, according to the slope. Suppose for this slope you can see it is 1:3, for vertical is to horizontal it is 1:3. So horizontal is to vertical, what is that, 3:1. So this you can see that the slope 3:1, so the correction factor is 4.5, okay. So 4.5, just look at the correction. The correction factor given above is to be multiplied by the horizontal length of the slope and divided by the distance between the two pile lines, okay. So what will be the value? That is correction factor for 3:1 is 4.5, right? It is 4.5. So 4.5 multiplied by horizontal length of the slope. What is the horizontal length of the slope? That is 3. 3 is the horizontal length. So it will be 4.5 into 3 divided by, you can see, divided by the distance between the two pile lines between which the slope is located. So what is the distance between the two pile lines? The two pile lines is this particular pile line and this particular pile line. So what is the distance? You can see it is 40 meter. So divided by 40 meter. Okay, so divided by 40 meter. So 4.5 into 3 divided by 40 meter. This is the correction. I have told you here we will be subtracting this value, and here there will be an addition of this particular value, okay. Have you understood? Then we will be proceeding with the problem. Yes or no? Have you understood? Are you listening, you people?
Yes, sir.
Okay. Okay, so next we are proceeding with the problem, okay. So look at this. The structure is given. Okay, so the structure is given, you can see that. Now we have to determine the pressure percentages at another thing I forgot to tell you is that the exit gradient, it is calculated by this particular formula. You can see that the exit gradient is equal to h by d into 1 by pi root over lambda. Lambda is already being calculated, right? It was calculated while considering the pressure value. You can see that if you don't use the graph, if you use the formula, then the lambda value, you can see it is being calculated. Lambda is equal to 1 plus root over 1 plus alpha square by 2, where alpha is b by d. B is the distance between the outermost piles, right? That is distance between the your upstream pile and the downstream pile. That is the value of b, and d is the depth of the pile, okay. So these have been calculated already. So So the exit gradient, you can see that 1 by pi you know 3.14, root over lambda is already known to us, it has been calculated. H by d, d is the depth, you can understand that is the vertical cutoff depth, okay, and h is the maximum seepage head. Maximum seepage head means, look, what is the maximum? So the maximum out here will be the pond level, that is maximum here, it is, you can see the reduced level is 158, okay. So it has been reduced to this particular value, okay. So the maximum difference, the depth, the difference will be this particular height, okay. So that is your h, that is your capital H value divided by d. So this is your exit gradient value denoted by GE, okay. So the safe exit gradient for that various type of soil sequence is given. For single, it should have a value from 0.2 to 0.25, okay. For coarse sand type of soil, it will be from 0.17 to 0.2, okay, and for fine sand it will be 0.14 to 0.17. So depending upon the various types of soil, your exit gradient should, the safe value is between these, okay. So we have to determine. So we are designing a particular wire. Suppose we are designing a particular wire, okay. Then we see that we know the type of soil. We have seen that the type of soil is suppose found out to be coarse sand. From the soil properties we have tested and all those things have been carried out, and we have seen that it is coarse sand, okay. So it should have a typical safe exit gradient value between 0.17 to 0.2. But from our calculations, while designing the wire, we have found out it is somewhere around 0.24, suppose 0.24. So we can say that that particular type of wire is not suitable for coarse sand, okay. So these are the things that needs to be seen or paid attention to, okay. Okay, so look at this problem. We have to determine the percentage pressures at various key points, okay. Also determine the exit gradient and plot the hydraulic gradient line for pond level on upstream and no flow on downstream, okay. So you can see that on the problem it has been told to us that there is no flow on the downstream side, so the seeping of water out here, there is no seeping, okay. So directly from that we can understand, okay, so directly from that we can understand the C3 value, this will be 0. Just try to get this point. This have been mentioned, there is no flow on downstream, okay. So the C3 value is 0. Otherwise, if it was being told to you that there is a pressure of, it should be mentioned, there is a pressure of 10% on the upstream side, due to which there is a flow, on the downstream side, due to which there is a mild flow. So in that case you would have considered C3 value as 10. Otherwise, if is mentioned like there is no flow on downstream, then you can easily understand this C3 value is 0 and this E1 value is 100, okay. So what are the rest of the values that we have to calculate? That is C1, E2, D2, C2 and E3, D3, okay. All the other two extreme values have been known to us, because the pressure head here will be maximum at E1, right. So now look at this problem. So firstly we are considering for upstream pile line number 1, okay. So we are considering for this pile, so what is the depth of the pile? Look, for the first case I have told you, again I am repeating, for the first simple structure what we do, we consider the top fiber of your floor as the floor only of like a sheet floor, okay. There is no thickness. we have considered the top fiber of the floor only, and from the top fiber there is the cutoff pile. Okay, so what is the top fiber? We have considered it like this, right? And from that the pile is there like this. For this particular pile we are considering. Okay, so just try to get what is the depth of the pile. The actual depth is from this point, right? So the actual depth is from this point, but in our consideration of simple profile, what we have to do, we have to consider it from the top, that is the top fiber. So the reduced level, you can see it is 154. Here the reduced level is 148. So what is the height? That is 154 minus 148, that is 6 meter. So 6 meter is the depth of the pile line number 1. Have everybody got it? I think you have. So the depth of the upstream pile line, you can see that it is 154 minus 148. Why again I am repeating why it is 154 minus 148? Because we are considering only the top fiber. Only this top fiber is being considered while we are considering the simple structure now, or the simple profile number 1. Okay, so while doing that, the top fiber is only considered, and the top fiber is at a reduced level of 154, and the bottom of your pile is reduced level of 148. So the height will be considering just from the top. Will be considering from the top. Actually it is from this point, but we have to consider from this top. Then from the formula what we can find out? We can find out the pressure at this point and the pressure at this point. Okay, then we have to do all those corrections in order to get the value at this point and this point. Okay, so in order to calculate these values, we will consider the depth to be 154 minus 148, that comes out to be 6 meter. Okay, the total floor length, it is 57 meter. You can see the total floor length is 57 meter. And just remember, the piles, the cutoff piles, the end cutoff piles, those are situated those are situated at a distance of 0.6 meter from the extreme ends of your wire floor. You can see that 0.6 meter from the downstream side, as well as 0.6 meter, look, 0.6 meter from the upstream side as well. Okay, so the 0.6 meter, it is being located at a distance of 0.6 meter from both the ends. Okay, your end cutoff piles. Okay, so your total length flow, that we have to consider right from this to this. So means we will consider this the structure to be a straight line like this. Okay, so the total floor length, you can see that it is 57 meter. So 57 meter is the total floor length. Okay, so what is the value of alpha? Alpha is B by D, that have been given in the formula, that is B by D, that is your 57 divided by 6, that turns out to be 9.8. Okay, so what is the value of 1 by alpha? This 1 by alpha is needed if we use the graph in order to find out these particular values. We'll see how the graphs are being how the graphs have been utilized. We will be seeing to it, but if you do it from the formula, you can also do it from the formula also. Okay, so how the formula can be used? Look, alpha is equal to B by D, so alpha turns out to be 9.5. so if you substitute these values, look, alpha, you know the value of alpha, that is 9.5. so you can find out the value of lambda, right? That is 1 plus root over 1 plus alpha square whole divided by 2. So lambda is known to us. So from that we can find out the value of phi E, right? We can find out the value of phi D. Okay, so from that we can find out the value of phi C1 and phi D1, right? Just again see that we are finding out first what we are doing, we are finding out the value of alpha, that is b by d. So once we find out that value, that is b by d, we can find out the value of lambda, that is 1 plus root over 1 plus alpha square whole divided by 2. We can find out that lambda value, and if we know the lambda value, we can find out this phi e and phi d. Then from phi, if we know the value of phi e, then we can easily find out phi c1, that is 100 minus phi e. Similarly, the phi d1 can also be found out, that is 100 minus phi d. Okay, so from that we can directly get these values, and also remember this particular value is 100 always, right? There is no loss of it at this point. So this have in any way this will be 100, and either we can use this formula to find out phi c1 phi d1, or also what we can do, we can use graph. Okay, these graphs will be provided in your exam. I don't know how much you will be able to understand this by this virtual procedure, because you won't be able to see it completely how the graphs have been utilized. Just try to see it. This particular graph, look, this is a line, this curved line, this is phi e. Okay, so this particular line denotes phi e. Okay, just try to get this point. Okay, and this particular value, this particular graph denotes, or sorry, this particular line denotes phi d. Okay, so if you have the graph, then you can get a clearer vision of it. If you have the graph, so this is phi e, this is phi d, these lines represent. Okay, and here you need not to concentrate on this particular line, just cross it out. Okay, so now look, this is the value of phi e and this is the value of phi d. Okay, so look here, this axis denotes your 1 by alpha value, this particular axis. Okay, this particular axis denotes 1 by alpha value. So up to this you have to do, in any case, whether you use the mathematical way or use the graphical way, you have to find out alpha. Then if you use the mathematical way, you need not to find this 1 by alpha, you can directly substitute these values and get your value. Okay, so but if you use the graph, then what you need to do, you have to find, as this axis represents your 1 by alpha, so you need to get the value of 1 by alpha, right? So 1 by alpha turns out to be 0.105. Okay, so from that particular graph, you have to locate where is the 0.105. Suppose it has been found out, it is here. Okay, the point, this corresponds to 0.105. Okay, so what we will be doing, we will be drawing a perpendicular to these two curved lines. Okay, we will be drawing perpendicular to these two curves. So the point at which it intersects, then we will be drawing a line parallel to your x axis. So what we will be doing, we will be drawing a line parallel to your x axis. Okay, and the point at which the vertical axis it intersects, that will be given as your either phi d value or phi e value. For this particular graph, that denotes your this particular curve, that denotes your phi e value. Look, this is the vertical we have constructed or extrapolated. Then we have just look at this red line, we have just drawn the parallel line to the x axis. So this turns out to be 29. Okay, 29. So this phi d value, we can see that this phi c, this is the graph for phi e. Okay, so the phi e value turns out to be 29. Again I repeat, what we will be doing, we will be finding out the value of 1 by alpha, because this axis represents your 1 by alpha. So we will be finding out that 1 by alpha. So from that point we will be drawing a perpendicular to the curve. Okay, to the curves we will be drawing perpendicular. What are the curves? That is phi e, either this curve and this curve. Okay, these two curves we will be drawing perpendicular to from the x axis, then from the point at which it intersects we will be drawing a horizontal line, and the line that intersects the vertical axis, that particular value will give us the phi e and phi d value. So for this particular phi e curve we will be getting the phi e value, so it turns out to be 29. From that we can easily calculate, so phi c1 equal to 100 minus phi e, that is 29, so that turns out to be 71. And for phi d1, that is 100 minus phi d, so what is the value of phi d? This is the curve. Okay, so we are drawing a perpendicular like this, and from that particular perpendicular we are drawing a horizontal like this, so this turns out to be 20. You can see this turns out to be 20, so 100 minus 20 is 80. Okay, have everybody understood? You tell me. Have you understood? Yes or no?
Yes, sir.
Okay. So these have been calculated. So what we have got? We have got the value of, actually the calculations that we have done, that is E1, C1, D1, there is no issue regarding this D1 value, but there is a correction that needs to be made for your, there is no change. We have found out the value of E1 here, so the value of E1 here will be same to that of here. Okay, so there won't be any change, but there will be a correction for the value of C1, because we have found out the C1 here. Okay, so we have found out the value of C1 here, but actually we have to find out the value here, so there has to be two corrections. There is no slope here for this particular part, there is no slope, so there won't be any correction for slope, but there will be two corrections. One is due to the interference of this intermediate pile, and another correction is due to the thickness of the floor. Okay, so we will be seeing how the corrections have been made. Look, the correction for the mutual interference of pile, that is given by this particular formula. I have already told you, this is given by the particular formula. So D is the, capital D is the depth of the influential pile. What is the depth of the influential pile? What is the depth? For that we will be considering this particular depth. Okay, not from the top of the floor, we are considering only the depth of the pile. So this is your depth of the pile, that is, you can understand the thickness, sorry, the pile is constructed from here. Okay, so you have to consider it from this point. So what is the depth of the pile? You can understand the reduced level is 154. Okay, and the thickness of the floor is 1 meter. So this, the reduced level here, that is RL 153, right? So it will be 153 minus 148. So the depth of the influential pile is 5 meter. Try to get this point. Okay, it is 5 meter. The capital D is 5 meter. While considering these particular calculations, we will be considering the depth of the pile from the top fiber, but for the correction part we will be considering only from this particular part. Okay, that is from the bottom fiber, or the fiber from which your cutoff pile has been constructed. Okay, so the depth turns out to be 5 meter. Okay, similarly the value of small d, here also we will be considering from this part. Okay, from this part we will be considering from this part, so that will also be 153. Okay, so this is reduced level 154 minus the thickness of the floor, that is 153, minus your this length, so the length turns out to be 5 meter as well here also. Okay, so 19 root over your capital D is 5, small d is also 5, B is known to us, that is the float distance, or you can say that the distance between the two extreme piles, or rather, sorry, here the extreme piles, you can see there 0.6 have been added on. So the distance between, the distance of the floor is actually the value of B. Okay, so that is 57 meter. So B is 57 meter. Small b is the distance between the two piles. You can see that the distance between the two piles means the distance between the your pile that is affected and the influential pile. So the distance here has been given by 15.8 meter. So when you substitute these values, we will be getting this particular value of correction. So what we need to do, the influential pile is located on the downstream side. So here we need to add it up. So the pressure developed due to this influential pile is more. Okay. So here the value that have been calculated will be added. Okay. So the correction is an additive one. Okay. Next is due to the thickness of the floor. I have told you we have found out the value of this particular value, that is C1, phi of C1. This turns out to be, look, this turns out to be 71. Right, you have calculated, it is 71. Look, phi of C1 is 71, and what is the phi of D1? It is 80. So this particular value is 80. Okay, so here there will also be one addition. So somewhere here in between, this should be greater than 71, right? It should be falling into the category of 71 to 80. So it should be more than 71. So here also we need to add it up. So by unitary method, we know that the thickness of the floor is 1 meter. So you can easily see how the correction has been made. The 80 by unitary method, 80 minus 71 whole divided by 154 minus 148. So 154 is this particular part, divided by 1 means this total length into your this particular length. Okay, so these have been calculated, you can understand that. Okay, if you have any problem you can ask me. So these are also be added on. So what is the net result? That is your 71 plus your influence due to the influential pile, that is 1.88, and the due to the thickness of the floor, that turns out to be 1.5. So when you add it up, we will be getting the phi C1 value, and that phi C1 value is at this particular juncture. Okay, so these have been calculated. Just tell me whether you people have any doubt. Otherwise we will be proceeding with the next class, and in the next class we will be doing the rest of the problem. If you have any problem, you can ask me. So in that case, if you don't have problem, you can leave. We will be starting with the next class. Right now the time is 2:21. We will be starting at sharp 2:25. Don't be late. Okay, we will be starting at sharp 2:25. In that case you can leave if you have no questions.